Coming to you with another SMO problem. This is a senior section back in, gosh, I don't know if I have this date right or not. That may be wrong. It may be 2021, but pardon the correction, or pardon the mistake. That's I'm not going to go about that. Maybe it's 2021. But in any event, we're given these initial conditions here. We're given sine theta is, I guess, a function of n-3 over n+5, and then cosine theta also is a function of n, a quotient. And this says for some n a member of Z. Now that's slightly confusing. That might indicate more than one or two solutions. You never know, but it says some n, which some people would read as just one. Okay, but let's just work through the math and see what happens. Now we're supposed to determine the maximum value of 160 times tangent squared theta, given these initial conditions here. Now the big result, it almost always crops up in a trig problem, it seems like, is the well-known result of sine squared plus cosine squared theta is equal to 1. So we'll write that down directly above where it's applicable here. So sine squared theta. Theta is typically thought of as an angle, but it could just be a real number. So sine squared theta plus cosine squared theta. This is really just a redefinition of the unit circle, also in trigonometric jargon. So we got cosine theta squared. And yeah, again, this is an identity, ladies and gentlemen, for any value. And the domain of this function is all real numbers. And so what we've done is simply re-expressed. Sine theta was given to be n-3 over n+5. It's a given condition up here, right? And similarly for cosine. Cosine is defined to be 4 minus 2n over n+5. And again, that's all given information. Often that's what you do in any problem, is write down your givens as quickly as you can and link it to some other result, which is what we've done right here. Okay, so again, this leads to this expression right here. And now, folks, I should say a little bit, it's just properties of exponents. If you square them, a fraction squared is the same as the numerator squared over the denominator squared. That's just a property of exponents, right? And also we have a built-in common denominator of n+5 quantity squared. Okay, now I put this in parentheses for my reading pleasure, or my just processing pleasure. I hope you like that. n-3 squared is equal to this, of course, and the parentheses may be considered to be superfluous, but for legibility, I like them. And the same thing right over here, okay? And then in the same step, we multiplied through by n+5 squared. There's a 1, all of a sudden, n+5 squared is over here, but that's n+5 squared times the 1 you see right here. The rest of this is fairly standard. We just collected like terms. You can see that a lot of stuff does cancel. These problems are designed to work, I've always said. 9 plus 16 is 25, cancels with this. So we're left with a very easy to factor expression right there. And it does factor, and we get the two values of n. You know, I like to write it like this. This is the solution set notation. It's understood that we're looking for n. So we get n equals to 0 and 8, as you can see from this factored expression. Now the question is, how do we maximize this? How do we maximize this? Well, we only have two possible cases. And y'all, this does tie back to sum. Some people might interpret sum up here to mean just one, but we actually ended up with two n's. And it's kind of hard to word these questions, actually. Sometimes the language doesn't wrap around the problem very nicely. But we do get two values of n equals 0 and n equals 8. And so let's just go ahead and do the case n equals 0. So for n equals 0, for n equals 0, that gives us 160. Now here's where I gotta be careful. 160. Now I'll go ahead and write the parentheses here, folks. Now if you put 0 here, you get 3. If you square 3, you get 9. And down here, if you put 0 here, you get 4. If you square 4, you get 16. So this would be 160 times 9 over 16 right here. 160 times 9 over 16. Now you're starting to see why they put the 160 in front. It's clever problem designers. Now let's try it out for n equals 8. N equals 8. Leads to, I should put commas here or something. marginally readable. Okay, so we have 160. All right, same sort of setup, folks. Now let's see what do we get here. When you put 8 right here, 8 minus 3 is 5. 5 squared is 25. I'll go ahead and record that. 25 over something yet to be determined. Okay, so if you put 8 right here, that's 16. 4 minus 16 is negative 11. Negative 11 squared is 121. Okay. Now, it's pretty clear which fraction's bigger. 9 over 16 is certainly larger than this fraction. So you don't have to do any complex arithmetic right here, right, folks? 9 over 16 is more than 1/2. 25 over 121 is much less than 1/2, right? 9 over 16, much bigger than 1/2. 25 over 121, much less than 1/2 or 1/4 even. So we know that this is our checkoff right here. N equals 0 induces the maximum value for the expression 160 times tangent squared. What is this? Oh, and you see it worked out really nice. I think in these SMO problems, the answers always come out to be integers. So in this case, the 16s cancel and we get 10 times 9 equals 90. Not to be confused with 90 degrees. Sort of a mishap when that kind of thing happens. It makes people think, oh, 90 degrees, yeah. But no, it's just an unscaled value here, or a dimensionless number. 90 is the correct answer. So let me know what you thought. I kind of like this problem.